Welcome to Easy Algebra. Today we want to take a look at absolute value equations and inequalities. Let's start with a simple overview of what absolute value is. Absolute value represents the distance from 0. The absolute value of x is shown like this. And that represents the distance from 0 on a number line. So if we have 0, there are two values that have an absolute value of x, and that is x to the right of 0 and negative x to the left of 0. So you always have two values that can be put into an absolute value. So let's look at a numeric example just to give us the concept. The absolute value of 2 is 2. It's 2 units away from 0. But the absolute value of negative 2 is also 2 because it's still 2 units away from 0. It's just to the left this time. But absolute value doesn't look at the sign. It only looks at the absolute distance. So now, how does this play out in an equation? Well, let's look at the simplest equation you could have. The absolute value of x equals 2. This is almost identical to what we just showed. Here we're saying there is a number x that has an absolute value of 2. There are two answers to this. X could be negative 2, or x could be positive 2. Because if we put these in, absolute value of negative 2 is 2, that's true, and the absolute value of positive 2 is 2, so that's true. So absolute value equations have two possible solutions. So let's look at a case where we're dealing with an absolute value equation that's a little more advanced than the absolute value of x equals 2. What steps do we do, and how? So before we look at an example in specifics, let's look at generic. If you have an absolute value equation in this form, so absolute value of ax plus b is equal to c. So either ax plus b equals negative c, or ax plus b is equal to positive c. And those are the only two possibilities. Now let's take that and let's apply it to an equation with actual numbers for a, b, and c. So here we have the absolute value of 2x minus 5 is equal to 7. We're going to take this and we're going to split it into two separate equations. So either 2x minus 5 is equal to 7, or 2x minus 5 is equal to negative 7. These are the two possible equations, and we solve them separately. So I'm just going to start with the positive case, and then we'll work our way over. So I'm going to add 5 to both sides. 5 cancels out, and we get 2x is equal to 12. We divide both sides by 2, and find that x is equal to 6. We've found our first solution. X could be 6. If we plug that back in, 2 times 6 is 12. 12 minus 5 is 7. And the absolute value of 7 is equal to 7. So that works out in the original equation, just as expected, right here. Now we look at the other case. What if we add 5 to both sides here? Again, these cancel out, and we get 2x is equal to negative 2. So we're still going to follow the same procedure. Divide both sides by 2. And we get x is equal to negative 1. This is our second solution. So now we plug it in. 2 times negative 1 is negative 2. Negative 2 minus 5 is negative 7. And the absolute value of negative 7 is equal to 7. So this also works back in the original equation. So these are both answers. There's several ways we can give this as answers. We could write these as x equals, I usually give these from least to greatest, negative 1 comma 6. That would be one way to show our solutions. Another perfectly valid way to show our solutions would be as a solution set, negative 1 comma 6. Both of these represent the solutions to our equation. Changing gears a little bit, what happens when you throw in an inequality? So now what's different is that this is no longer an equal to. It's a less than. So before we look at this problem specifically, let's look at the general case. If you have absolute value of x is greater than 2, we have two possibilities here. You could have that x is greater than 2. That's the simplest case. You could also have x has a relationship with negative 2. And here's where we have to be careful. We're introducing a negative. And would it be true if you had, we'll say, absolute value of 4 is greater than 2? That's a true statement because negative 4, 4 is greater than 2. So in the positive case, 4 is greater than 2. But is negative 4 greater than negative 2? Well, no, negative 4 is less. So here, when you put that negative, the sign flips. So here, x would be less than negative 2. So here we come up with a universal statement. When we introduce the negative, the sign flips. So here, what we find is, if we were to graph these two values, here's negative 2, here's 0, and here's 2, smaller than negative 2 would be out in this direction. Something like that. Greater than 2 would be in this direction, like that. So here, this is an or. When you have a greater than symbol, we put in an or, and your absolute value is going to go in opposite directions. What if we had a less than symbol? So here we've introduced the same equation, but we've switched the symbol to be less than. So we'll follow the same rule. X is less than 2, and here x is greater than negative 2. But when we graph these, we find that the relationship's a little different. We have 2 here, and we want to go to everything to the right, or from negative 2, and everything to the left of 2. So these connect like this. We call this an AND statement. So we have a disjunction and a conjunction. When you have that less than symbol towards the absolute value, that is an AND statement. So now we're going to apply this to our inequality problem. So we had 3x plus 1 is less than 5. Because that's a less than, we're looking at this case here. So we're going to use the word AND, which means that when we have a graph, they'll be coming towards each other, or there will be no graph at all. So we're going to split this to 3x plus 1 is less than 5, and 3x plus 1 is greater than negative 5. So we'll work the one on the left first. We'll subtract 1 from both sides. So 3x is less than 4. Divide by 3, and x is less than 4 thirds. We'll deal with that fraction in a moment. We still have the conjunction and, so we'll subtract 1 over here. We get 3x is greater than negative 6. Divide by 3 on both sides, and we get x is greater than negative 2. So now we have our system, and we can graph this. So if this is 0, here's negative 2, 1, and 2. 4 thirds is 1 and 1 third. So we'll put some little markers in here that are thirds. So that's 1, and those are 1 and 1 third, 1 and 2 thirds. So we're going from here to here, and everything in between. And of course, we need to fill in shade everything between them, like this. Now there's one more way we can write this, and that is we can combine it. X is greater than -2 and less than 4/3. This would be our solution, and that would be our graph.